Hi, sorry about that. It took us a little while to get started, but let's get rolling. My name is Josh Wills. My talk today is titled Elementary Worldly Data Science. And I will talk about why it's that title in a minute, I guess. Sort of a strange title. A little bit about me. I work at Slack. I've been at Slack for 3.5 years. I was Slack's first director of data engineering way back in the day. I built the team from, well, like, I guess one engineer to about 15 or so, started hiring managers, discovered in the process that I did not really care for management that much. So there's an old sort of hoary chestnut about law school that it is a pie eating contest where first prize is more pie. And that was roughly how I felt about management. It was just, you know, kind of I looked up the chain and it was like there was just a lot more pie up there, basically, is what I was saying. So I worked on Slack's search infrastructure for about a year, rebuilding Slack Search, which was super fun, and I've talked about that at some other conferences. And now I work on Slack's tooling and systems infrastructure, so things like how we build services, how we run experiments, how we configure things, sort of all that good stuff. I was at Cloudera for 4 years before that. I was largely a professionally famous data scientist, which is a pretty great job. I recommend it to anyone if you get a chance to do it. And before that, I worked at Google. So I worked in Google's ad auction for a couple of years. So if you ever did a search on Google and ad showed up, that was me. You're welcome. Yeah. And then I worked on Google's data infrastructure for a couple of years. I wrote one of Google's experiment frameworks, a lot of stuff that got used in Google News, a lot of stuff that got used in Google Mobile Search, and for better or worse, a lot of stuff that got used in Google+. So anyway, that's a little bit about me. Slack, before I go any further, does anyone not know what Slack is? Any Google employees here? No? Oh, sick burn. No. I literally actually once bumped into a colleague of mine from Google in California and told him I worked at Slack, and he got really excited because he thought I was working at the Stanford Linear Accelerator. That's what he thought I was doing. Anyway, if you don't use Slack, Slack is basically like Kafka for people. It's a way for your organization to like chat and collaborate and work on things together very, very quickly, and people seem to like using it. When I agreed to give this talk, I had no idea that S1s would be filed and that kind of stuff, which limits, to a certain extent, the things I'm allowed to talk about today. So I'm not going to talk about Slack that much, and if you were coming to hear about Slack, I apologize. But I hope it's interesting all the same. I've spent the last, I guess, like maybe 6 months or so meditating on failure would be like the way I would describe it. I spent a lot of time over the last 6 months, last year, thinking about failure. And thinking about all kinds of different failure. And the genesis of this meditation was my sort of recent work doing a lot of monitoring, building services and figuring out how to monitor them and figure out like when things were going wrong with the service. So I've been a data science person my whole life. I've been a data person my whole life. I spent most of my time in the offline world building like big batch data pipelines, building big batch offline models. And I had not done a ton of online sort of systems work until I started working on search. And so there was a whole set of tools around like Logstash, like the ELK, Elasticsearch, all that kind of stuff, Prometheus for counters, like all tools that I had never really used. And then I got really, really interested in working on. And in particular, I got interested in working on them in the context of monitoring machine learning models. And for what it's worth, there's an excellent, excellent paper by the good people at Google called your ML test score, like the ML test rubric. It was written by D. Scully, who actually is a professor at Tufts, and a few other folks. And it's basically all about how to monitor and test production machine learning infrastructure. Highly, highly recommend the paper. I gave a talk that was essentially devoted to nothing but the paper at QCon a few months ago. And the great thing about like working on monitoring was that the analogy I would draw was sort of like when you first learn about like unit testing systems, when you start learning about unit testing your code. And you're sort of like, well, this is kind of a tedious chore that I don't really want to do, but you know, it's important, I think, because people who are smart tell me that it's important. And then when you actually like kind of get into it, you discover that thinking about testing and thinking about testability makes you write better code. It makes you design better code. And the same principle applies to monitoring. When you're thinking really, really hard about how is my system going to fail? How is it going to stop working? What is it going to look like when it stops working? What am I going to do when it stops working? You end up designing better systems. Like thinking really hard about like problems kind of from the point of view of failure can be like a great guiding light to help you build better stuff. And this line of thinking sort of led me, as it does, just kind of the way my mind works, to thinking about organizational decision making and how data-driven organizations make decisions and how those decisions like work out, how they fail, how they could be improved, all that sort of good stuff. And that's mostly what I want to talk about today. But as an aside, I got interested in this stuff, like I said, about 6 months ago. And I turned, my 40th birthday was at the end of March. And so kind of like about 6 months or so before my 40th birthday, I got really, really, really interested in decision making. And I'm like subscribing to the Farnham Street blog, and I'm reading all these books and like all this kind of stuff, just obsessed with decision making. I was mentioning this to a friend of mine, and she said to me, "Oh, so you're going through your midlife crisis?" And it kind of like dawned on me, like, yeah, basically I was going through my midlife crisis. That was more or less what it was. So this is my midlife crisis in talk form for your benefit, so that when you go to your own midlife crisis, you can have some reference material to go on. Okay. Have not bought the McLaren yet, in case anyone was wondering. Although there's a Tesla store like right over here, right? So you can just walk over anytime and fulfill all kinds of midlife crisis fantasies. Okay. In my reading, during the 6 months of reading, one of the favorite papers I read, essays I read, talks I read actually, is this one called Elementary Worldly Wisdom, and it was written by this guy right here, who's named Charlie Munger. And I love this picture of him, because I just like, this is like my resting bitch face, basically, like right here. This is like just the way I sort of look. It's like kind of like that. He gave this talk at the USC, University of Southern California Business School, back in 1994. And I don't know that it's been like written up in a book anywhere, but if you Google online for Elementary World Wisdom, you can find a link to it. And it's a great read. And it's a great read about how he thinks about problems and how he thinks about decision making. And most of this talk is honestly just like kind of commentary on that paper, basically. So if you wanted to like open it up and read it along as I was talking, that would in no way hurt my feelings whatsoever. But I found it just like incredibly useful as a framing device for thinking about decision making. And sort of his core premise is that to make good decisions, you need this thing that he calls a lattice of mental models. A lattice of mental models. And he goes into sort of detail about what he considers to be a mental model. A mental model is just a tool for thinking. It's a way of organizing your thoughts, organizing your facts around time-tested principles that have been shown to be useful by humans for a very, very, very long period of time. The idea that we want to do is we want to take the very best ideas from every discipline. So it's not just about math, it's not just about economics, it's not just about biology, it's not just about anything. It's about every sort of the really, really good, brilliant ideas from every discipline, organized, integrated in our heads, used as a decision-making device. And I say to myself, okay, this sounds great. As a data scientist, I'm used to ripping off ideas from lots of different disciplines, putting them to my own advantage, be it software engineering, be it statistics, be it whatever domain I'm working on. I love this. This is my jam. I'm on board. So that's where I got started. The best ideas from every discipline arrayed into a form of mental models. And the one that he starts with in the talk is basically elementary mathematics. He refers to them as the elementary permutations and combinations, like the very, very basic kind of binomial theorem level stuff, aspects of probability. And he says that if you don't know how to do this, you will always be a one-legged man in an ass-kicking contest, which is just a phenomenally good analogy that I'm going to use all the time now. Like, it's just really, really handy. But if you cannot think quantitatively, you are basically screwed. And that's, and again, this is speaking my language, like he's talking to me, right? I agree with that. To the extent that data science has done anything in industry over the last decade or so, it's really just kind of this, right? Like, I think I joke on a fairly frequent basis that data science is like advanced counting with like an occasional division sort of here and there. Like, I don't feel like there's anything I do day to day that is like truly rocket science in any sort of sense. It's all very simple, straightforward, high school algebra basically, just applied to real world problems. And Charlie gives the example of the decision theory class at the Harvard Business School, which is basically what they do. It's like, how do we make decisions? We build decision trees, and then we kind of walk the decision trees and follow the probabilities of things. And it's all like very simple, straightforward ways to sort of think and organize your world. And when I think of like what has been so successful about truly data-driven companies like Google and Facebook and so on and so forth, has been the ability to kind of apply these principles at sort of every level of scale of the organization. And that's what I want to talk about a little bit more. In particular, the combination of like quantitative thinking and the ability to like invert problems and think about them from the end instead of from the beginning is just an incredibly powerful tool for making better decisions. This is a reference to, there was a famous analysis done during World War II of large planes that had come back to Air Force bases during the war and basically where they had been shot up, where they had taken enemy fire. So basically they like got all this data together, they built a big chart of like, this is what our planes look like, and these are all the places where they keep getting shot. So the obvious thing to do, let's just put some extra armor on the places where they get shot so that they won't get shot there quite so much anymore. No big deal. Data scientist of the day looks at this and says, nope, not quite. What we actually want to do is add more armor to the places where there are no holes. Because those are the places where if the plane gets shot, the plane doesn't come back. The places where the plane gets shot and comes back, who cares? That's fine, the plane made it home, right? Places where we don't see any holes, those are the bad spots. Those are the spots where the planes that did not get returned come back down. My favorite example of this at Google was a problem that we worked on for a couple of years during my time there, which is called snippet optimization. So when you do a search on Google, and then you get the list of 10 search results, right? And there's a little snippet next to each one which shows you kind of like some context from the page. Everyone's familiar with this, right? Think about snippets as a data scientist. I have two algorithms for showing people snippets, like selecting snippets from a page and showing them on there. How do I figure out which snippet algorithm is better? Legitimately hard question, right? Because it's like, if the snippet's doing a better job of showing people like answers on the page, then they won't click on them as often, right? But if they are doing a worse job, they'll click more. But if the snippet's showing you stuff that maybe is relevant on this page, you should go click on it then, right? Does this kind of make sense? Like it's sort of, you end up in this circular sort of situation where you can't really figure out, is this actually like, doing a good job or not? And so Google spent literally in my time there a year trying to figure out a way to decide which snippet algorithm or which approach to optimizing snippet algorithms would be better. And ultimately what they did was basically punted on the question, like just completely punted on the question and looked at the problem from a higher level, which is, what are we trying to do with the snippet algorithm? What are we trying to do with every single algorithm we do at Google? We're trying to get people to search more. That's it. That is fundamentally what we're trying to do. We're trying to get people to search more often, to use search more often. We cannot tell the difference between these two things. So instead of trying to like find a good metric to optimize, let's try to find a bad metric that we want to a bad thing to track that we want to eliminate. How do we like create, if we can't figure out how to create more positive behavior, let's try to eliminate known negative behavior. And this has like been an incredibly useful tactic to me like my entire career. If you find yourself in a situation where you can't agree on a good North Star metric, you can't like find a path forward to go to, try inverting the problem and thinking about how to eliminate bad stuff. How do I measure the bad stuff that I know I don't want to have happen, no matter what else is going on, and then let me focus hard on eliminating that. That's like a really, really helpful way for complex problems, for very nasty integrated systems where you can't kind of tease things apart. It's a great way to help you like make better decisions and build better models. That said, if it is possible, if you find yourself in a situation where you can actually decompose your business into a set of individual metrics, each of which can be optimized by different teams, you can build a really, really, really powerful growth engine. And Google like very much operated this way. There was a search team, and the search team's job was to get people to search more. And there was an ads team, and the ads team job was to get Google more money per search. So one team is focused on increasing search, the other team is focused on increasing revenue per search. You multiply A times B, you get more money. It's a fantastic model. Like honestly, if you can do this, this is incredibly powerful. Facebook has like taken this and like actually put it on steroids. Facebook has like 3 large areas, each of which has a different focus. The growth team is trying to increase DAUs, daily active users. The core product team is trying to increase time spent per DAU. And the ads optimization team is trying to increase revenue per minute spent on Facebook. A times B times C equals money. It works like stunningly, stunningly well, and I don't have any other evidence to support that other than the very, very large stock prices of these companies. If it is possible to decompose a problem into these little tiny pieces like this, break your business up this way, what this really fundamentally lets you do is identify bottlenecks in your system. If you can break things down this way, you can basically see where you are not growing and where you need to be applying resources in order to grow more, in order to move things forward. In the enterprise software business, at Slack, at Cloudera, other enterprise software companies, things don't generally decompose quite this cleanly. It's never quite obvious, like, what is the combination of features and pricing and packaging and revenue and relationships that contribute to like executing a sale, right? It's a combination of things, and we can't like cleanly decompose these things. And so it becomes much, much, much harder to identify the bottlenecks in the system that are holding back growth. So you kind of end up doing a lot of different things. Whereas when you have this decomposable business model, when you can apply elementary permutations and combinations to your core business, it becomes possible to scale things a lot faster. Favorite example of this kind of decision making. Has anyone ever heard of the 41 Shades of Blue experiment? Do people know what I'm talking about? A few people know. This is a fairly old thing. So back in 2008, there was a team at Google whose job it was to optimize the ads user interface. This was all they did. It was a team of about 20, 25, mostly new college grads, and all they did all day was run experiments on the user interface. Move pixels around, change the color of things, adjust the organization, anything you could think of, any experiment they could run, this was their job. I think at the time I was there, launching a new, better machine learning model would generate like an incremental $150 million in revenue per year for Google. The ads UI team did one launch there that made $600 million in incremental revenue for Google. It was like an incredibly, incredibly powerful, profitable team. And one of their experiments came across a change in a little tiny bar that you would never notice in your life from one shade of blue to another that generated an incremental $200 million a year. It's a lot of money. Very, very tiny bar, very, very small and consequential thing. And the designer who had designed the sort of search user interface and worked on the search team was aghast at this choice of blue, at this shade of blue. It didn't fit into he was basically creating an overall color scheme for the page, and changing this particular shade of blue to this other color made the design like inelegant, kind of ruined the sort of holistic integration of the overall page. And so Google, and in particular Marissa Mayer, who was in charge of search product at the time, was faced with this decision. On the one hand, you have the designer who was arguing for this shade of blue, and on the other time, you have the $200 million in the ads team, which is arguing for this other shade of blue. And the question then is, how do we make the decision? How do we choose what we're going to do? And I love these kinds of stories because they are so utterly revealing about what companies care about and how sort of politics and power works inside of companies. And the sort of the choice that Marissa made, and to be fair, not an easy decision. This is like an impossible situation she's in. That's the nature of the job. She ran experiments. She ran 41 different experiments exploring kind of a whole spectrum of blues in between the two. And she chose one in the middle. She chose one that was kind of the knee of the graph. She basically chose to make everyone unhappy as opposed to making any individual person like kind of win one or the other. The reason we know about the story is the designer in question, who's named Doug Stopford, left Google to become chief designer of Twitter and wrote about the story. And he wrote about this and he was like very much incensed. I, at the time, working on the ads team, was also incensed. I was incensed that we didn't choose the original color of blue because, the $200 million, right? I wanted my bonus. My bonus depended on like a lot of Google making a lot of money off of ads team, and that was a lot of money, so that kind of thing. And it was just, if anything, it was the fact that they ran an experiment, the fact that they ran 41, like sort of these 41 different sort of treatments to really kind of fully explore the space was just like the most googly way to make the decision possible. Like it just honest, I cannot give you any better description of how decision making works at Google than that. It is like the mathematics of elementary permutations and combinations applied on like the largest possible scale at every single level of the company. And this is true at Facebook as well. And this is true with something that they call growth accounting. Has anyone ever heard of growth accounting? Folks know growth accounting? This is a big deal at Facebook. Growth accounting is like a religion at Facebook. Growth is a religion at Facebook. Growth accounting is like, I guess, the Bible, I would say, roughly speaking. This is how Facebook keeps track of their daily active users over time, of their monthly active users over time. They break them down into new signups, resurrected users, people who dropped off that came back, people who churned out, and then, I'm sorry, I guess this is differentiating between existing user churn and new user churn. So existing user churn, long tenured users that dropped out. New user churn, people who just signed up, but then basically never came back. And in the same way that Facebook decomposes its business into daily active users, time spent, and then revenue per unit time, they decompose their DAUs down into these different categories. And they have teams that are focused on each of these different categories, on optimizing signups, preventing new user churn, preventing existing user churn, so on and so forth, right? They've created these like very, very powerful quantitative abstractions that allow them to make these numbers move at like very, very large scales. So that's all great. In Charlie's talk, though, he talks about accounting as well. He actually talks about accounting in the context of building oil refineries and how this guy who built oil refineries in the 50s and like basically looked at how accountants were doing oil refinery, like how they were doing accounts receivable, accounts payable, and like handling depreciation of assets and all this kind of stuff, and said essentially this is nonsense. That none of this makes any sense, and I'm going to build my own new accounting model for how we build oil refineries. And the thesis here, and the hard thing, and I think the hardest thing for data scientists, is remembering that the map is not the territory, that the model is not the reality. The word is not the thing that describes. Whenever the map gets confused with the territory, a semantic disturbance is set up in the organism, and the disturbance continues until the limitation of the map is recognized. And I feel like I could summarize like 2017, 2018, the last few years as like a large-scale exercise in Facebook and Google discovering that the map is not the territory. And I want to kind of like go through a few examples of what I mean by that. When I worked on the ad system at Google, you basically experience these systems through dashboards. And I would imagine this is a very dashboard-heavy audience, right? Like we live through dashboards. We see the world through dashboards. We see the world through numbers, boxes, screens, all this kind of great stuff. And when you were thinking about problems at this scale, it's incredibly helpful and incredibly powerful to be able to reason about the systems from the numbers you see on the screen. And it is incredibly difficult to remember that there are actual people on the other side of these numbers, like deep down in the details, that are doing things that you can't see. And when we think about like Facebook these days, or when we think about a lot of the problems I want to talk about here, there are a couple of very useful razors, like thought razors, right? Occam's razor, simplest explanation is always best. Does anyone know Hanlon's razor? Slightly less useful. Hanlon's razor. Never attribute to malice that which can be explained through stupidity. Okay? And I want you to keep Hanlon's razor in mind when we talk about Facebook. I don't think Facebook people are malicious. I don't even actually think they're stupid. But I think they are working inside of a system that causes them to make mistakes, basically, would be the way to think about it. It's a system that is designed to make mistakes. And they're not like the first people to do this, not even close. I would actually say that it seems like humanity is going to have to go through some sort of global crisis every decade or so for the next century until we start figuring this stuff out. Because at its core, the global financial crisis, 2007, 2008, was also a result of the map, people basically confusing the map for the territory. Folks remember CDSs, CDOs, collateralized debt obligations, bond models, right? It's a great article in Wired that actually I linked to in the notes for the slides if you want to get them later, about the Gaussian copula model that was developed by a professor named David Lee. The Gaussian copula model was how we measure the risk of a portfolio of diverse assets. So I'm taking a whole bunch of mortgage bonds and I'm slicing them up into tranches and I'm repackaging them together. How do I know what the risk return model should be for this tranche, right? Or this tranche, excuse me. David's model was how they did it. And it was a model that was heavily, heavily, heavily used, that was heavily, heavily, heavily trusted by financial people who were, again, looking at the stuff completely abstracted away from the reality of it, just many, many, many levels, all calculated through this model that was telling them the risk of these uncorrelated assets was totally fine because there was no real problem, like whatever. Simply because the assumptions to the model were wrong. There was vastly more correlation than anyone realized from the historical data. It was a great example of like the map not being the territory. Like we trusted the model handled the risk for us. And not for nothing, models generally do a great job of handling risk for us. We've like grown as a society, as a civilization, because we've gotten vastly better at handling financial risk over the time. And honestly, the thought was in 2006, 2007, that we had discovered a new innovation that was actually helping us manage risk far better than we ever would before. If we hadn't have thought that, we wouldn't have built all this ridiculously insane stuff, right? We would not have caused this crisis. The Facebook version of that is sort of like Facebook and Russia. And I think, we've seen it take a long time for Facebook to kind of own up to the Russia problem. Like their initial kind of response to like Russia showing ads on Facebook, in fact, ads like this one, for instance, telling you don't bother voting, just tweet a hashtag on Twitter because that's basically good enough, which honestly, if it was, that would be fantastic. But nonetheless, the reason Facebook didn't see this is not because they're malicious, and honestly, it's not because they're indifferent. It's because they're working on a different kind of class of problems. And I sort of try to put myself in the position of a Facebook ads engineer back when I was like, if I was thinking of my time in Google, right? What was I thinking about? What were the problems I was worried about when I was working at Google Ads, right? It certainly was not like people hijacking elections, like not even close. I was primarily worried about spam. I was primarily worried about large-scale, organized crime, whatever, sort of manipulations of the ad system that were designed to undermine the credibility of the overall ecosystem, right? To basically make advertisers lose trust in the system because someone else was going to profit at their expense. That was my primary sort of like concern, is the overall sort of like health of the system, the stability of the system, the trust of the system. That is my concern. And so all of my dashboards and all of the problems I'm thinking about and all the things I'm looking at on any given day are focused on that problem, the large-scale systemic stuff, right? And I have no doubt that Facebook was absolutely, from their perspective, correctly focused on keeping spam out of the news feed, on the overall sort of like broad-scale health of the ecosystem, these macro threats. And something like Facebook showing like 100,000 ads to 100,000 people across 3 states is nothing. It doesn't even exist as far as they're concerned. It's basically invisible at the scale of the problems they're thinking at and the scale of that they look at the data, right? The scale that they think about things, their systems. And in Charlie's talk, I think the thing that he thinks of that was most helpful to me is that we go wrong when we think about these systems as math equations. We go wrong when we think about them purely in this way, and when we stop thinking about them as ecosystems. Like from Facebook's perspective, from my perspective as an ad engineer, it's like you're a bear and you're worried about some other bear coming. Like I mean, Google and Facebook, I guess, are actually like pretty good bears in this context. These bears are like worried about fighting each other for shared resources. They're worried about like large-scale problems. They're not given any thought at all to the tiny little virus that's like getting into their bloodstream and is the thing that's actually going to kill them, right? They don't think about things at these level. And like, I don't know much about biology. I mean, I was very much an indifferent biology student, primarily because I thought math was the end-all be-all in my high school days. So I don't know this kind of stuff, but I'm like deeply curious now about how these defense systems evolve, right? How does like our biological immune system evolve to like keep us safe from viruses at the same time we're worried about fighting off predators, we're worried about getting enough food. Like, how do all these systems work together? Because the problem I see at like large-scale data companies these days is really around, we're worried about these big macro things. We're worried about getting eaten by the bear. We're not worried about the viruses. How do we develop the systems that are designed to fight against the viruses? Like, how do we figure out how to do this? It's not something we are like, it's not something our equation-driven sort of perspective on how these things work is really like primed us to think about or give a lot of thought to. It's all about the ecosystems. All right. The other sort of like, the compounding problem here is another essay Charlie gave called The Psychology of Human Misjudgment. that aside from the math and aside from the models and aside from the accounting and aside from the ecosystems, there's a whole class of errors we make just because we have biases, right? We're flawed. And one of the most powerful ones is the incentive bias, by far. People are really, really, really good at not figuring out things that would potentially interfere with their income streams, broadly speaking, right? And we see this like over and over and over again. And this again is true, this is true at Facebook, this is true at Google, it's true at every data-driven company. When your bonus depends on a certain number hitting a certain thing, that's what you're gonna do. That's just the way it works. That's just the way people are, right? These biases are like very much limiting for us, and limiting in sort of the approach that we are, the amount of dedication and effort that we are willing to bring to certain classes of problems, just because we're simply blind to them. We don't give them nearly enough thought. The next part of his talk is about economics, about microeconomics, and in particular economies of scale and the importance of economies of scale. The example he gives is volume and surface area, right? So volume grows cubically with the radius, but the surface area only grows as the square of the radius. And what that means is basically that's economies of scale in a nutshell. A smaller amount of actual material, like each incremental sort of unit of like surface material, like metal or whatever, allows you to create a larger volume. And it just keeps growing and growing and growing. That's basically what economies of scale mean. You can use less resources to create more value as you go up the chain. And there's a book I highly recommend called 7 Powers. 7 Powers is written by a Stanford Business School professor, and it is all about the 7 different ways to create differentiated, sustained competitive advantage and profits in business. And I absolutely love this book because it is like, again, I'm a very quantitative person. There are a lot of equations in this book, like far more equations than you would expect in a business book, and I just absolutely loved it for this reason. And one of the case studies in this book is Netflix. And Netflix is absolutely fascinating to me because Netflix is one of those companies that really started out like as a Google, Facebook style data company where they were focused on recommendations and doing the Netflix prize and all that kind of stuff. And they have evolved and they have sort of discovered over the last 10 years that they aren't really a data company per se. They are an economies of scale company. They are a company that can spend billions of dollars buying content because they have a subscriber base that is large enough that allows them to amortize those billions of dollars over the lifetime value of that larger set of customers. And that is an incredible, incredible advantage for them. And that is now like the core of their business, the core of their growth engine. I just love this picture and I had to include it in the talk for this reason. But let's talk about why you shouldn't cross Jane Fonda. So a couple of years ago, there was an article published in the Wall Street Journal, I linked to it here in the other thing, about a debate at Netflix over some advertisements for this show that stars Jane Fonda and Lily Tomlin, which is called, I think it's called Gracie and Frankie. I don't actually watch the show, I'm sorry, I'm not. Gracie and Frankie, good show? Like people like it, that kind of thing? Okay, it's good, it's funny, all right, gotcha. Anyway, I mean, it has this image, so like what's not to like? Netflix was doing some A/B testing of ads for the show, and they discovered during the A/B testing that the ads that only showed Lily Tomlin and did not show Jane Fonda did better than the ads that included Jane Fonda. And this led to, again, sort of a 41 Shades of Blue crisis at the company because the people in Hollywood, the people who were managing the relationships that Netflix was creating with the content people, were deeply concerned that it would offend Jane Fonda if the primary large ads they were showing did not include her, and it only included Lily Tomlin. And they were afraid of the downstream implications of this for other deals and all kinds of stuff like that. So Netflix was having this internal debate between the content people and the data people. And this time, the content people won. The content people won. By the way, just sort of pro tip, whenever you see one of these internal deliberations leaked, it's the loser who leaks it, just in case anyone doesn't know that, right? So when the design team at Google, they're the ones who leaked that, right? The data team at Netflix decided to leak this to the Wall Street Journal. And that is like absolutely fascinating to me. The data team of all people like us, our peers, decided to share this fact that Netflix was not quite as data-driven as it claimed it was, because it was concerned basically about, and quite potentially correctly, about offending Jane Fonda and hurting kind of future relationships. And so again, going with this thesis that like these kinds of decisions inside of companies tell you what really matters and they tell you where power lies, says to me that the content team at Netflix, people who are responsible for signing these large deals, these very, very large content deals that Netflix sees as the key to its future, have far more power than the data team does now. The things have kind of turned around a little bit. And as I think about this, I am somewhat empathetic with the content team, I would say. Like I don't actually necessarily come down with the data team on this decision. Because fundamentally, Jane Fonda does have some amount of power in Hollywood. Her agent has some amount of power. Her production company has some amount of power. It's not nothing. I can't quantify it. I can't put it into my model. I can't A/B test it. But it does exist. It is a real thing, right? And when I think about this stuff, what I'm mostly interested in these days is how do we make decisions when we have these sort of competing factors, right? When we actually have this, we have quantitative modeling, we also have these sort of qualitative factors that are very real. Just because we can't measure them, it doesn't mean they don't exist. And then how do we integrate these things together to make better decisions, not just individually, but as organizations? And that led me to the book Astroball, which is utterly, utterly fantastic. And if you get a chance to read it, I highly recommend it. It was written by this man named Ben Reitner, and I have to like kind of look closely here because his name's on there, sorry. The picture you see on the left here is the cover of Sports Illustrated in 2014 with the headline, "Your 2017 World Series Champs, the Houston Astros." And the picture you see on the right is a picture of the Houston Astros winning the World Series in 2017. And the reason this was kind of like great and sort of fantastic is that in 2014, the Astros were the worst team in baseball. And it like wasn't even close. They were by far the absolute worst team in baseball. And in many ways, they were like kind of a joke. But Ben got to sit with them and spend a lot of time with them. And amazingly, his prediction in 2017 came true. And it turns out that if you correctly predict the winner of the World Series 3 years in advance, you get a book deal. So something for everyone to look forward to. And he wrote fundamentally about how the Astros had basically gone beyond Moneyball to make better decisions. And the guy at the sort of the core of it, the general manager of the Astros, used to be in charge of scouting for the St. Louis Cardinals. St. Louis Cardinals are a very kind of old school classic franchise, not really like kind of into this whole Moneyball stuff. But still, he was a former management consultant, former McKinsey guy, very, very into numbers. And he brought kind of Moneyball style thinking to their scouting, to their draft selection program. But he was always kind of this weird outlier with the St. Louis Cardinals. Because again, like the rest of the organization, not really a bunch of data people, very classic, old school, that kind of stuff. So when he got the chance to like lead an entire organization, to become the general manager of the Astros, the question was really like, what was he going to do? Was he going to do like the Moneyball thing and just sort of like dismiss all of the non-quantitative people? Or was he going to like how exactly was this going to work? And I'm sort of like curious about this. Google and Facebook were built to be data companies like from the beginning. This is a situation where like a baseball franchise was not really a data shop becomes led by this data-driven person. Like what exactly was he going to do? How was he going to integrate all this stuff together? And it was fascinating to me was what he came up with was a model that is honestly not dissimilar than what Bridgewater does. Does everyone know what Bridgewater is? Bridgewater is a famous hedge fund led by a man named Ray Dalio. He wrote a book called Principles recently. And it's sort of like the most nutso place you can possibly imagine working. This is actually like a screenshot from like one of their internal apps. Every single meeting that you have at Bridgewater has this sort of like this app called Dots, where you list a bunch of qualities of people. And as the meeting progresses, you score everybody in the meeting and how well they are doing living up to these different qualities, like how they're measured by them, right? And after the meeting is over, all of this information is published for everyone in the company to see. Everyone's opinion is published to see everywhere, right? Sounds like basically insane, right? But also kind of awesome, right? And the genesis of this is really what's great about like stock picking or hedge funds, and honestly what's great about like picking baseball players as well, is that you can make a large number of decisions that you don't actually have to like suffer the consequences from, right? You can basically do I'm going to create a synthetic portfolio. I'm going to create a synthetic portfolio of players. I'm going to rate every single baseball player in this draft, and then we're going to track and see how well do these players do in their Major League Baseball career, like over time. How well do they do? Same thing for stocks, same thing for baseball players. And that's essentially what the Astros do. No matter what your perspective is, no matter like what kind of like whatever your background is as an old school scout or as a quant or whatever it is, whatever perspective you're bringing, you can give a ranked list of who you think is going to be the best player in a given baseball draft, and we can track that over time, and we can use that information to build models that give us an idea of how good your assessment is of different players under different conditions, under different qualities, all that kind of stuff. And so there's this very kind of clearly transparent decision-making process that the Astros have imposed across the entire organization. We don't dismiss qualitative thinking, but we do integrate it into our overall quantitative process. We acknowledge that it has value, and to the extent that we can, even if we can't decompose the value into its separable pieces into a model, we still try to track it at the macro scale over time and make it a part of things. If only so that everyone knows where they stand, and so that there's clarity around how decisions are made at the organizational level, no matter what your background is, no matter where you come from. And that, to me, that was what I loved about Google. That was the stuff that was great about working in a data-driven organization, because it meant that no matter who you were, if you'd been there for 3 days or 30 years, if you had an idea, you were allowed to test it, and you were measured on how well that idea performed exactly the same way everybody else was, using those big dashboards that I spent a lot of my time in. And that is the best way to me to work. That is not just is it a great, profitable way to build a company, it's a deeply, deeply, profoundly satisfying way to work. At the same time, the Astros still have to make qualitative decisions. They have to make decisions about whether or not to trade for Justin Verlander ahead of the trade deadline in 2017. And they did trade for him, and it ended up working out well. Justin Verlander, if you don't know, is arguably one of the best pitchers of all time, but he's also much older, and it was a big question for them, where they basically just kind of had to make a gut decision, and they were honest about that, right? They didn't try to dress up the decision with data. They just said, look, this is a hard call. We're going to make a hard call. That's just the way it is, right? And finally, I think the thing I love best about this book is about Astroball is that they're honest about their mistakes. In particular, they were mistaken about a player named J.D. Martinez, who currently plays for the Red Sox and is a perennial MVP. J.D. Martinez used to play for the Astros, but he was a terrible hitter. He had a 200-something batting average, just barely good enough to stay in the majors. And in the offseason, he went to work with a hitting coach, and the hitting coach worked with lots of baseball players and said to J.D. Martinez, you have the absolute worst swing I have ever seen in my life. And yet you were still a Major League Baseball player, right? With terrible mechanics, with absolutely terrible mechanics, you are still a Major League Baseball player. So let's see what we can do with you if we actually make your swing better. And so he did. He worked all winter, made his swing much better, goes into camp, basically says to the Astros, hey, I worked on my swing all summer. Give me a chance. Let me show you what I can do. And the Astros basically have models, and the models say that hitters don't get better in their 30s, right? Players don't improve substantially their hitting over the course of their career. So they dismissed him, and they let him go. And he went to play for the Tigers, and he won the MVP. He hit 400 in June. It was kind of insane. He's an unbelievably gifted player. And so it's back to the sort of basic theme, which is the map is not the territory. We cannot account for the growth of people. We cannot account for the growth of companies. We cannot account for having the virtues of having a growth mindset in our models. And to the extent that we do that, we will make these sort of embarrassing mistakes. And the Astros, again, to their credit, very, very publicly call this a fuck up in their book. Very, very, this was bad. We screwed up. This was the limits of our models. And something that we would all just be vastly better off doing. I think we'd all just be much happier with each other, at least, if we did that more often. I mentioned the midlife crisis thing, right? This is all about decision-making in organizations, decision-making with data. I was curious about Charlie Munger and Warren Buffett. In his talk, Munger says that Buffett has the ability to think in elementary permutations and combinations, at a very fundamental level. He just does it naturally. And I was thinking that I don't really make many data-driven decisions in my life, broadly speaking. I do not personally use data to decide where to go work, who to marry, whether to have children, where to live, all this kind of stuff. I know some people try to. I don't personally do it. And I think what was interesting to me was the extent to which, reading about Warren Buffett's life, I read a biography of him called The Snowball, was how just basically deeply messed up his personal life is. He's really, it's you read about your heroes and you read about people who can do these kinds of things that are just truly, truly amazing. And when you kind of go deeper, you sort of learn how limited they are as people in some ways, how their strengths, the things they lean on, the things that they derive a great power from, can be deeply limiting them in the rest of their life. He had a terrible relationship with his parents. He has a lot of like difficulty with conflict. He has lots of difficulty handling any kind of severe emotion. He's in many ways a brilliant and fascinating man, but also not like necessarily a well-rounded human that you would want to aspire to. And so, I don't know, I'm probably still in the midst of my midlife crisis. I don't think it's quite over yet, I think. But the obsession with decision making, at least for my personal life, has abated somewhat. So I guess I'll just go get my Tesla and be on my way. Thank you all very much. I appreciate it. Oh, Slack's hiring, right? All right. Okay. Cool. If anyone has any questions for whatever reason about anything, there's a microphone up here if you want to come speak to it. If you don't mind coming up, just because they can't record you any other way, I don't think. If we don't have any questions, that's okay too. You have a question. You want to go to the microphone or you want me to repeat it? Okay, all right, cool. Yeah. Yes.
So the competitors, which is basically the other teams
Yes.
in the league, how far behind are they in terms of creating that data-driven?
Yeah.
Is that actually paid as competitive advantage because they have it, other teams don't?
Yeah, exactly. So do the Astros, like, at this point, do the Astros have a competitive advantage?
Yeah.
It's a great question. I'm not under the impression that competitive advantages last very long in baseball, right? Moneyball comes out, the Red Sox adopt those principles, and they win the 2004 World Series, right? There's a very strong motivation, I think, to adapt this stuff quickly. I think the thing that's harder to me, I think, is the cultural aspect of it. Like, is really the kind of, I think in some ways it's the joke about culture eats strategy for breakfast. Like, the adopting, it's the, my favorite item in the 7 Powers book is actually the Toyota production system. It's like, it's the 7th power, right? People talk about operational excellence, they talk about execution as an advantage, but basically no one really does it. Like, it doesn't really actually exist. There's not like a differentiated, like, with like operational excellence, except for Toyota. Toyota is like the one exception, right? And what's crazy about the Toyota production system to me is they invite everybody in. GM, Ford, anybody. Like, come walk our factories, come see how we work, come see what we do. They're super transparent about it, right? And yet somehow, after doing it for 50 or 60 years, it's like so dyed in the wool and the fiber that, again, I can't figure out why. It shouldn't be possible, but there it is, it exists. So, like, I gotta be accountable. And I would think if I was the Astros, I wouldn't mind sharing this kind of stuff, because I would say that the cultural advantage of this sort of stuff is so much harder to get into your system than the sort of operational, tactical, dot-centric decision-making, right? You could do the dot thing anywhere, but if it's not part of your culture, it's just gonna be like an absolute disaster, And I think it's like when we say, like, you look at the dot thing and you're like rating people in meetings and stuff, that just sounds like an absolute catastrophe. And it's because it would be. It would be an absolute catastrophe almost anywhere. And the fact that Bridgewater can even try to do it is kind of like indicative about what kind of culture they have. Anyway, cool. Hey, how you doing? Yeah, come on up.
Hey, thanks so much for your talk. Do we still have time for questions?
Yeah, I think so. I think I got a couple minutes, right? I can keep talking? I can't see anyone telling me not to.
Okay,
so
sounds good.
Yeah, okay.
Yeah, thanks again for your talk. Really appreciate the way you think about things, think about the world, and I can relate to it. My question is, how do you actually implement some of these mental models and frameworks? Like Inversion, for instance. Big fan of Farnham Street, read their article about it. It sounds amazing, but I have trouble actually using it, whether in my personal life or at work. So how do you do that?
I think the technique that's been most helpful to me along the idea of inversion is the pre-mortem. Pre-mortem. Have you heard of the term pre-mortem?
Yeah.
Okay, pre-mortem. Like, I had a friend who recently changed companies. He was going to be the director of data engineering and machine learning at a company. And he was basically asking me for advice on making the decision. Mm-hmm. And he asked me, let's do the pre-mortem exercise. It's 6 months from now. My tenure has been an absolute disaster. Why? Mm-hmm. Why was it? And the answer I had for him, the honest answer was, because the company he was going to did not actually need data and machine learning at the scale that he needed it. Mm-hmm. That was like the most likely reason why things would go off the rails. It was usually like a sort of systemic effort of it. Mm-hmm. And I generally find that, like, thinking from, it's sort of like back to the original idea, which is like thinking hard about failure, assuming failure, and thinking about what you do under failure circumstances, I just find to be incredibly instructive and useful. So for whatever it is you're thinking about, when I was deciding, I lived in Austin for a long time. And when I was deciding to come out here to go work for Google, which in many ways like changed my life, changed my career, I was agonizing over the decision, like absolutely agonizing over it for like maybe 6 months. I'm a great agonizer over decisions. And the thing that clicked it for me, and I don't know why, was my therapist said to me, I don't know anyone who's ever regretted moving to San Francisco. And I don't know what that was, what it was for me, but that was kind of like, that was the thing. It was like, yeah, I don't see any, regardless of Google, regardless of anything else, I don't know that I would ever regret having lived in San Francisco. That said, it's been 10 years. I'm kind of tired of San Francisco now, but I definitely don't regret moving there. So yeah, pre-mortems, yeah, and I guess changing sort of the lens, the perspective on the decision, I guess, are my two big things.
Okay, cool. Thanks. That's helpful.
Thanks. Oh, I'm sorry, man. Okay, cool. Thanks, everybody.